Assalamualaikum warahmatullahi wabarakatuh and hi, we're from group 5 and we are going to explain about colligative properties. Common features of colligative properties. Common features of colligative properties are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So what is the meaning of colligative properties? Colligative properties of a solution are properties depending upon the concentration of solid molecules or ions of the solution and not upon the identity of the solid itself.
The elevation of boiling point. What is elevation of boiling point? Elevation of boiling point is a colligative property, the phenomenon where the boiling point of solutions are higher than that of the pure solvent. The boiling points of the pure solvent and the solution is proportional to the concentration of solid particles.
Let's talk about the causes of boiling point elevation. Some of the causes include the amount of solid, vapor pressure, and temperature. The amount of solid affects the boiling point elevation as the greater the concentration of solid in the solution, the greater the boiling point elevation. Vapor pressure. The greater the pressure, the more energy is required for liquids to boil and the higher the boiling point. Lastly is temperature. Boiling point of a liquid increases with the increase in temperature pressure. Now, let's move on to how to calculate the elevation of boiling point. The amount of boiling point elevated is determined by using the equation delta Tb equals to Tb solution minus Tb solvent, which resulting in Kb times N. Delta Tb is the boiling point elevation, while Kb is the boiling point elevation constant, and N is the molality of the solid. As an example in the slide shown, it explains how to calculate the boiling point of 3.5% solution by weight of sodium chloride in water. First, calculate its moles in 1 kg of solution, then calculate its molality. Since natrium chloride dissociates into 2 ions, the 1/2 factor for this compound is 2. Therefore, the boiling point elevation can be calculated as delta Tb equals to 2 times 0.52 OC per molar times 0.619 molar, which equals to 0.643 OC. Since the equation requires by weight, then boiling point of solution equals to boiling point of pure solvent plus boiling point elevation. Therefore, boiling point of the 3.5% natrium chloride solution is 100.643 OC.
Applications of boiling elevation. Antifreeze. Antifreeze elevates the boiling point of the water in car radiator, and by doing so, the water does not reach its boiling point. It helps to protect against boilovers, especially during hot weather, as overheated engine can be damaged severely. Secondly, cooking. Adding salt to water before heating will increase its boiling point. The water will actually be hotter than it would normally be when it comes to a boil. It will take slightly longer to boil as its boiling point has been elevated. Sugar refining. To produce cane sugar, the sugarcane juice is extracted and boiled. The sugar concentration will determine the temperature of boiling point. Thus, boiling point elevation can be used to monitor the level of saturation of the solution, which is crucial for crystallization.
Now, let's have a look at the depression of freezing point. Freezing depression is colligative property observed in solutions that results from the introduction of solute molecules to solvent. When freezing, the movement of molecules in the substance slow down due to low temperature. Intermolecular forces start to take over. The molecules will arrange themselves in a pattern, then become solid. When solute is added, the formation of the solid becomes larger. Hence, the solution must be cooled to an even lower temperature to achieve a solid. In terms of vapor pressure, adding of solute will dilute the solvent molecules. This leads to a decrease in vapor pressure. Vapor pressure of the solid and liquid forms must be equal at freezing point to have an equilibrium system. The diagram shows the effect of solute on physical properties.
From the explanation, we can quantify the freezing point deflection into an equation which is delta dF equal to dF of solvent minus dF of solution, where delta dF is the freezing point deflection and it is common to write as delta dF equal to Kf times m. Kf is the freezing point constant and m is the molarity of the solution, which giving us the information on how much of solutes in the solution. Therefore, from the formula, we can know that freezing point is directly proportional to the molarity. This is due to the adding of solutes causing the freezing point to become lower. Generally, freezing point of the solution will be lower than its pure solvent. Next, there are some applications of freezing point depletion that used in our daily life. First, ice cream seller makes ice cream by adding salt into the bucket of the ice in order to lower the freezing point of the water coming off the ice cube. This will help in the ice cream formation without forming in ice cube. Second, lower the freezing point of the water in automobile cooling system by adding antifreeze agents such as ethylene glycol and propylene glycol to prevent the automobile engine from bursting due to expansion when water freezes. Moreover, most of the countries will apply the salt to ice roads to lower the freezing point of the ice during winter season. This is because to let the ice melt faster and making the road safer for driving.